All right, so I got the motor ripped apart because we do have the oil smoke problem. And we were doing a compression test, and I found I think it was the second or third cylinder back. No, it must have been the third cylinder back on the passenger side there had no compression. All the other cylinders was good. And with it burning oil, and it seemed like it was only coming out of the passenger head, that led me to believe that I had maybe a blown head gasket into the crankcase, you know, not into a cooling passage. And that's where it was, the engine was sucking, you know, the manifold vacuum was sucking backwards through the cylinder, you know, kind of from crankcase. So we're pulling this motor apart. Now, yeah, definitely you can see I got some dirt down in there. I used compressed air to blow off the intake manifold many times, and that was the best I could do. I still got those crumbs in there, so I'll probably get a vacuum cleaner. I'll try to vacuum up as much of the big stuff as I can. And you notice that kind of that push rod that's just chilling there. Yeah, so that may contribute. I still haven't got that valve cover off. That may have been what, I still think the head gasket is blown because of all the oil smoke, but this may have been what actually blew the head gasket. Is if that, I think if that's an exhaust valve, that would make it more likely. If that's an intake valve push rod, then I guess that doesn't make as much sense in my head, but we'll see when we get this further pulled apart. And this intake, it was covered in mouse crap, and you can still see there's some. I scraped off as much of it as I could. First I used a flathead screwdriver, and then I used a you know, steel brush. I don't know if that'll focus with that light, but it's cleaner. You can kind of tell. Anyway, the other thing is I blocked off this exhaust crossover, and you can see that there. That's just JB Weld. I stuffed a little bit of newspaper in there, and then I put the JB Weld on top. So what that'll do is, because we live in a really hot climate, I don't really have issues, you know, it's not really that cold in the winter, so I shouldn't have any problems with the fuel vaporizing in the winter, and I'm not really as worried about the engine warming up quickly, but I should make a little bit more power, you know, not a lot, but a little bit, because this intake manifold will be cooler. I don't think I've had fuel percolation problems with this one, but then again, I haven't run it enough, and I haven't run it enough in the summer to really know. I do know with the old Ford truck that I had, I used to have fuel percolation problems. You know, you shut off the key on a hot day and you could hear the carburetor boiling the gasoline. So I will block off, of course, the exhaust crossover in that engine also. But so this will prevent that, the fuel in the carburetor from boiling. And if the air in the intake is a little bit cooler, it should be a little bit more dense. The only thing is, I did leave the other side unblocked. You can see it's still open. I only blocked that one side. I did that so that my EGR valve still works. I am going to leave the EGR valve. So I think, the EGR, I think it helps the engine run a little bit cooler because, of course, it's in a largely inert gas and it takes up space in the engine, so the engine burns less fuel, you know, less air and fuel. It's the mixture. There's less of the explosive mixture going in, and there's more of the inert gas going in to take up space. So, you know, at part throttle, when the EGR valve opens, it'll help improve your economy a little bit. And of course, at full throttle, it should shut off the EGR valve. And so, you know, you get as much air and fuel in there as possible. All right, so we had a total of 3 bent push rods. All 3 of them were on intake valves. I believe I know what happened. On the way home with this thing, I would put it into third gear and let out the clutch to engine brake down long hills. So with the engine not running and with no oil pressure, the hydraulic lifters weren't pumped up. And so going from 0 up to, you know, 4,000 or something very rapidly like that, numerous times, it happened definitely more than once, that's probably what caused those push rods to bend. So probably if this motor is, you know, running correctly and the lifters are pumped up, that won't be a problem in the future. You should be able to engine brake just fine. The camshaft that was in it, you know, it had GM8 and 3041 stamped into it. Of course, the 3041 is the last 4 digits of the GM part number, but of course I don't have the whole cam part number. It's very difficult to figure out, you know, what grind that cam is, but we do know it's a stock GM cam. Of course, it was new with the motor, and these I can't put it on camera now because, of course, I have a camshaft in there, but those cam bearings are brand new. Like, this is a brand new motor. So I pulled out the stock cam. I saved all the lifters in order, and actually, despite the fact that this push rod actually hit the cam. You could see the spot on the cam where that hit. I think the cam survived. So I kept all the lifters in order, and I think I'll be able to save that cam and use it for a different project. Since this truck is so heavy and it's going to have so much weight, I'm changing the cam. This is a Melling part number 22214. It is a 214 degree duration, both intake and exhaust at 50 thousandths, of course. So it's a symmetrical cam, same duration for the intake and exhaust lobe. It is a 502 thousandths gross valve lift, so that's of course at the valve, not at the cam. 114 degree lobe separation angle. It has a 5 degree advance ground into it, and I'm advancing this an additional 4 degrees, so there'll be a total of 9 degrees advance on the cam. That puts my intake lobe center line at 105 degrees. So this should be, you should put a lot more air into the engine, should make some more power, and so hopefully at full throttle this thing, plus not just having a beefier cam, but also having working push rods, this thing should make a grotesque torque. So for the weight of it, I think I'd be happier with this versus a stock cam. And then if I ever end up, you know, I'm 23, I got probably quite a few years left until I die. Probably somewhere along the way I'll end up with just a truck that just has a 454 in it, and the cam will be old and worn out, and I'll throw in my newish stock cam, and that'll be fine for just a pickup truck. And then this I'll have a mean cam just because it's, I think this was rated for 19,500 pounds on the truck. So, and I don't know if I mentioned or not, but these are high-flowing heads. They're not a peanut port. So somebody put nicer heads on this. Beyond that, I believe this is just a stock rebuild. So that's part of the reason that we have the 9 degrees advance on the camshaft. We want to, as much as possible, preserve our dynamic compression ratio, because originally these had 8 1/4 to 1, I think, static compression. Now, probably the block was milled, probably the heads were milled. So, you know, we might have pushed it as far as 8 1/2 to 1, but it's still going to be a very low compression ratio. I don't expect that this has the compression raised at all. And of course, it's, I think, you know, I'd have to look down a spark plug hole and see if the pistons are domed or anything like that, but I don't think it is. It's a stock camshaft. It's just they cleaned up a stock engine and threw it in here. So, and I think, I'll be honest with you, I'd almost like to advance the camshaft a little bit more than 9 degrees, but I think I'll settle for 9 because that's what I can get away with, practically speaking. I'll probably reuse the old timing set that was in here because it's a very low mileage timing set. So you imagine, you know, it might end up slightly stretched, and so that'll retard it a degree or two, and that'll cancel out some of my 9 degrees of advance anyway, even though I would probably like it to be actually 9 degrees advanced rather than losing one of those. But I think we'll be okay. I think we'll be able to make some decent torque numbers with that. Okay, so the ring gear is completely destroyed. So you know, I pulled out the transmission for the purpose of the ring gear, but we're doing some adventures along the way. So the issue I was having with this transmission is it would get stuck in fourth, and it did it fairly often. And so I believe what happened here is the yoke, for the PTO, you know, there's this is the shift lever that engages the PTO, and there's a yoke that goes over there that runs the little mini, you know, PTO drive shaft. I think the guys that rebuilt the motor, they actually broke off this bolt. So I came in, this bolt was broken off, no attempt was made to drill it out. So all the drilling I did, I drilled 2 holes, one slightly smaller and one halfway slightly larger, just so I could get the easy out to engage a little bit better. You can see there's kind of a hole in the bottom of that. This feels very light in my hands. It's very hollow. And I put the easy out in there, and I hammered on it while I turned it to make sure it was shoved in there real good. It took a lot of force, but I was able to get that cracked loose, and I was able to get the yoke off. And that's important because I have to replace that seal. You can see this puddle. This transmission leaks down incredibly quickly. It's really bad. I mean, you can see it's leaking right now. It's almost empty. And I filled this transmission up when I got the truck. So I mean, I don't know if you can tell, the fill plug is right below that ridge. So the fluid should be up to that rib right there, and it's not. You can see it's way down there. So in no time at all, this thing leaks down through that, I believe, just that one seal. I might try to replace the shifting seal also if I can get to it. We'll see how hard that is. I imagine it's the same seal. This one is a 1-inch, you know, I want to say bore. No, it's a 1-inch shaft, and then a 1.5-inch bore that the seal goes into. 1-inch ground shaft, I should say, and a 1.5-inch bore. So hopefully if I can replace that seal, this will hold fluid. And that was why it was getting stuck in fourth. This thing was run dry, and I don't know if you can see it, but we can look here and you can see, watch that. Yeah, you can kind of see what's happening there. And that's why this would get stuck in fourth, is that's fourth gear right there, is you're locking the input, you know, to the output. And so this shaft here is the output, down below is the counter shaft, and then this is the input. And so normally your gears, they go input, down that set of gears, and then you select which gear it comes up, whether it comes up through this one, comes up through this one is reverse, or it comes up through this one. I think this is first gear, the most reduction, because this is the biggest. I think this is second, this is third, and then this one right here is fourth. So it actually, in second, it would pop out. No, that would be what, this one here. I don't know. Oh, I think I might know the answer to that. But anyway, so I'm going to rip out this input shaft and replace the input bearing, which is here, of course. And there's also, I believe there's a bearing under that gear that I will try my best to replace. I don't want to get a whole kit. The kits are expensive, and the synchronizers on this work well, so I have no motivation to rebuild it. It works fine. I don't see any need for that. But this one is easy to find. You just SM465 input bearing. This one might be harder, because I'd have to figure out what you'd call that. But anyway, I will try to replace that one also. And of course the two seals. And so that should largely fix our transmission. Whoop. I will have to get a new parking brake shoes. These were, of course, fatalities. Most of the material is still on there, but you can see these don't look good. Yeah, I don't know if you can see. I think these got greasy. I'm not exactly sure where the grease came out from, but the inside of the drum was actually wet when I got it off. If I can find the drum. So it wouldn't hurt to replace those shoes. And part of it is, you notice these rivet holes. That one you can kind of see the hole, but this one, the hole is actually filled in with crap. I think it's a mixture of dried, cooked grease and also, you know, shoe material. So here's our parking brake drum, and you can see it's kind of looks a little bit gross, and I think that's because it was trying to brake while greasy. My great uncle told me that this parking brake did actually hold the truck really good. He said he'd used this as a parking brake, and it did an excellent job of holding the truck. And that's greasy, mind, so if we put it together without grease, I'm sure it'll be even better. And of course you notice the crack. I think that's the only crack. I'm probably going to run it though. Sorry. My apologies. As for why this was popping out of second, you can see this is what it's meant to look like, okay? So you can kind of see it's smooth across there, and you can see the wear mark from where that little kind of dog clutch is rubbing, but the wear mark and over here, it's pretty flat. And then this here, of course, is a damaged one. It was not happy running dry. And you can see that big, if you could focus, that big indentation there. I guess I should double check and verify that this is second. But yeah, you can see all that kind of mushrooming at the end. So this was not happy running dry. I think that is the second one, gear one, isn't it? Let's see. Yeah, that is the one that does second gear. Because you can see here, it's the furthest back, dog. So it's back here. This is the one that it does back unsynchronized first, and that's those nice coarse teeth. And then up, even though it's moving this, not spur cut gear, this is the, this is for what it reverse engages to. But even though it's moving that, you can actually see it's squeezing that synchronizer, and that's going to be the second gear synchronizer. So, and that's in the kind of the front of the transmission direction, and front of the transmission direction, there you go. And it's worn out here, that's the front. So yeah, that's exactly why it was popping out a second. It did it very seldom, but it would do it. I think it only did it twice for me, and then there was a few times where I wanted it to stay in second for an extended period, and I would just rest my hand gently on it. And the parking brake mechanism was missing a bolt too. I think I know which bolt that was. So when I put that all back together, I'll put it together with one more bolt. The shoes needed a little bit of an adjustment. Of course, it's moot now because I have to replace the shoes, but I'll get it adjusted nicely. And then there is an adjuster on the parking brake that I'm sure at some point I'll show you. But yeah, I'll try to get it as tight as possible. With the little adjuster down here, it looks just like a car, that guy. Yeah, you see it. But I'll try to get that one as tight as possible. And then the shoes will wear a little bit as they seat, and then that'll loosen the adjustment a little bit, but then you can take the rest of it up with the knob. And so ideally, you'll never have to crawl under the truck, would be the goal. And you can adjust it from in the cab. Oh, and the speedometer cable is broken. I don't know if it was always broken or if it got broken in the process of coming out, but it doesn't look good. It's very possible that was always broken. I do know that the other end of the speedometer the other end of the cable wasn't spinning, so it's very likely that that was broken, so that'll probably have to get replaced too. A lot of work this. Got a new master cylinder, brake master cylinder on the way. The other one was leaking. I can show you what it looks like, I suppose. The master cylinder that I'm going to put on it is going to look slightly different. This is a $200 piece of equipment here, so I think try to save myself, I would rather not spend $200 on a master cylinder. And these trucks in this year came with a couple of different master cylinder options. I believe they were both of them were power brakes. I don't know why it would have come with one master cylinder over the other, to be honest with you. I do know the main difference is this one has a spring, and I think it's a 1-inch bore. Don't quote me on that, but you'll understand the premise. The other one doesn't have a spring, and it's, I want to say, a 1.5-inch bore, but again, don't quote me. I'd have to look it up. Shoot, I can't remember. I believe the purpose of the spring is that the brake booster is too powerful for this master cylinder, and so the spring actually helps the master cylinder return. I was actually having an issue with the truck. You step on the brakes, and if the rear tires were in, like a fine silty dirt, there's no weight in the rear end. So the rear tires would lock, and you'd slide, and you'd remove your foot from the brake pedal, and the rear tires would remain locked, and you would continue sliding. So this master cylinder was staying depressed, even when you physically removed your foot from the pedal. So I'm hoping that the other master cylinder with the larger bore will be, more happy to return the pedal, and so you won't lock the brakes like that. You'll be able to release your foot and undo the lock brakes there. I think I'm going to replace the center support bearing while I'm in here. It's only like $28, so. And I've greased already. I've greased everything on the truck that could be greased, but of course obviously that doesn't do a lot of good when it doesn't start and it doesn't come out of fourth. So, oh, and the other thing is I think I have a bit of a vacuum leak, and I do know that the axle doesn't like to shift. There's nothing wrong with the axle. I've checked that, and there's nothing wrong with the diaphragm back here. I actually ordered a replacement diaphragm, and so I have it on hand. If this one ever stops working, I can just swap it. I have it around here somewhere. And I've jacked this truck up in the air and put it in gear. And I've taken the vacuum line and swapped it back and forth, and ka-chunk, ka-chunk, and it switches back and forth perfect. I did that a bunch of times, but when you shift it in the cab from the cable, a lot of times it doesn't do anything. Sometimes it will, sometimes it does nothing. So, and plus the engine acts like it has a little bit of a vacuum leak. I've turned the idle screw out about as far as it'll go, and it idles just maybe a hint fast, which might indicate an air leak. And I think the torque at idle isn't great. Like, it doesn't want to die per se, but it doesn't make quite as much torque as I would think. You know, again, at idle, it doesn't make a lot of torque, but it's slightly more eager to die than I would expect. So I'm hoping if I can take that apart, that valve, I don't know that I can replace it. I tried looking at it, hard time finding them. But if I can take it apart and get it working better, hopefully leaking less, I might be able to, you know, overhaul it with just what I have. Then hopefully that'll fix my vacuum leak. I can up the idle screw a little bit. It'll idle a little bit stronger, and then the axle will actually shift every time I do the knob. So we'll see in a little bit. Okay, I hope you'll forgive. It's like, you know, 105 degrees out here, and as you can see, the sun's a little bit intense, and it's messing with our contrast. But I wanted to get this rear, you know, output off, that, I guess, spindle you might call it. I had a nut on there. Now I have a set of, you know, big nuts here, or excuse me, big sockets, but they go up to 38 millimeter. That was quite a bit too small. Of course, the sets like this that, you know, your AutoZone rents only go up to 38 millimeter. I ordered a special rental set from AutoZone. That one went up to 41 millimeter, and I put a little caliper on that nut, and it measured you know, 46.9, so basically 47 millimeter, or obviously this would be standard, you know, whatever the standard equivalent of that is, but, you know, either way would work. Any socket that would go on it, but, you know, short of special ordering something, I was not going to be able to find a socket quite this big. So it occurred to me, I had one of these laying around. You might have one of these at home. This one my great-grandfather left me. It's a really old one, but, you know, it's got those 4 posts. This is for a special type of axle nut, you know. And it occurred to me that this might be big enough, and I thought, you know, maybe that'll just jam on the nut. And I put it on there, and tink, 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 you know, it was real tight, just like a good socket. And so I put the air impact on it at full force, and it popped it right off, and it might have dinged it up a little bit. Yeah, so, you know, I mean, I don't think the nut went completely unscathed, but I think it's only that one corner that was bopped. I think all the rest of them are okay. So, I don't think this is going to come on and off often enough for that to really matter. And then I can, you know, pop out these 4 bolts, and hopefully I can get this plate off. It'll make it a lot easier to remove that rear cover and get to the clip on that rear bearing so the countershaft can go forward and fall down. It was going to be a huge pain. It's probably possible. I have a special tool, but it would be a huge pain. It'd be a lot easier if I could just get this off. And I did want to inspect that rear seal. The inside of the parking brake drum was a little bit, you know, wet with lubricant. It almost looked like a grease, but it was probably just a you know, gear oil, or in this case, you know, it'd have to be like a GL3 in back gear oil that doesn't have sulfur in it because of the brass or bronze synchronizers. You can't put modern gear oil in this, but I digress. You know, it was probably a transmission fluid that got hot, and it slowly cooked itself down to a thicker substance that looked like grease. These shoes were actually dry, but they were covered in powder, and I think it, because it was driven with the parking brake on at some point, and it probably cooked whatever it was, whether it was grease or fluid, it cooked it down until it was a dry powder on the shoes. So I got new shoes for it. I believe just a, you know, regular 1967 C10 shoes will fit, not a C20, not a C30. The C10 shoes match the parking brake drum shoes on this one. And I think the same thing with the hardware kit on that. They are, I forget, I think it was a 11-inch inner diameter drum. It was 11-inch even because the drum is stamped. It says maximum diameter 11.090. And I think you could get a 11.2-inch drum on the 67 C10, but that's not it. You want the 11-inch even. And I think these were just a sniff over 2 inches in width. So you'll see, you know, if you look it up at your parts store, you'll see the one that's 11 by 2.07 or something like that, and that's the one you want, at least in my case. Whereas the other one, I think, 11.2 by 2.5 or something like that. Anyway, so yeah, I definitely I really wanted to inspect that seal and make sure it wasn't going to leak any fluid onto my new shoes once I get them in there. Well, and I found the source of the fluid, of course, for the rear parking brake drum. You look at how I'm pushing on this seal and it's not flexing, like at all. And if I do push on it, I don't know if you can, it's not doing it now, but there was a spot over here I pushed on it and I could physically hear it make a cracking noise, and you can see, if you look super, super close, there are cracks in it. But yeah, this seal's really, really dry. It's probably an age thing more than a temperature thing. I don't think it would have gotten that hot for any particular reason. And like, you imagine if it did get hot from running low on fluid, the front seal is still soft. So I would expect, oh, you know what? It was from driving with the parking brake on. That might have been what got this hot. Because it definitely looks like the parking brake was driven in the on position. Yeah, so that probably was a new seal. And I really like this metal gear. That's pretty. I know some of them use plastic ones. I don't know how common the metal is versus the plastic, but I think that's kind of neat. I don't know that you'll be able to see it. These rollers, they did have traces of grease on them still, but they also have metal shavings on them. And obviously you see the discoloration on my fingers. When I look really closely, I can see little sparkles. Like I can see, they're very small pieces of metal, but I can clearly see the metal when I look at that kind of that dark smear on my fingers. So I'll clean up the inside of the input shaft and the front of that output shaft, and I'll make sure that there's not a lot of damage. It's kind of a bummer that I'm not seeing damage on this roller, if you'd focus. Which is a bad sign. Because I want to see damage on the roller, because I want replacing the rollers to improve the situation, right? If I replace the rollers and the race on the input shaft is bad, that doesn't do me a lot of good. So we'll do the best that we can. This thing doesn't, I can feel it in my hand flopping. It's probably hard to see. It's a lot more obvious with the input shaft in it. I don't know if you can see that or not, but it does flop a little bit, but I'm sure that's more than the new one's gonna flop. I don't think I got footage of it. I used RTV to glue an old thermostat gasket onto the back of this master cylinder. And I don't know if you'll be able to see this or not, but there's an indent on the back of the master cylinder, which is a problem. You see that indent? Well, that needs to seal the vacuum, but you can actually see that thermostat gasket in there, and that actually takes up that space, and it sticks out far enough that it sticks out past those flanges. And I left the booster side dry. It was only RTV on the master cylinder side, and then I let it actually cure in the shop, so that anytime I remove this, the thermostat seal stays with the master cylinder, and it's removable, and I can replace it. And I took a wire brush and I cleaned up that rust. I think I got this mostly bled. I will probably adjust it a little bit. There's a screw in there that I'll unscrew, because there's just a tiny bit more clearance between the pedal and the beginning of the master cylinder than I'd like. I think it was only 20 bucks for like a new center support bearing. This one's a little bit stiff. Part of it is I think the rubber is like rubbing on the dust shield, but I don't feel any crunching, but it's old, so it's only like 20 bucks, so I'll replace that. I think all the other U-joints are good, except for this one, and I'll show you why. You can see, obviously this is good, but here, look at that. I don't know if you can tell or not. It's like, it's not me, it's popping. Boink, boink, right there, like it's, ew. there's like a couple of detents in there. It's hard to, you know, obviously you can't feel it, but I felt all the other U-joints. They actually feel fine. I greased them, but they feel smooth, and there's no looseness in them whatsoever. It's only this one. I don't know if the heat from the parking brake would have affected that at all, so we'll just probably replace the one. And this is how I had to get the that countershaft bearing. So this is the bottom front. You notice that ring was on the back side, so this was pressed in and the ring was covered, and there's those two little divots in the transmission that I can show you, and those are meant so that you can grab that ring. Those are right here. Yeah, so those are those two little slots are so you can grab this ring, but the ring is supposed to be on the outside so you can grab it. So when you put the ring on the inside and you press this in, the ring gets buried and there's nothing for you to grab here. So I tried just about everything, and this is the only way I was able to get it out, was by welding it on there, taking a crowbar and just kind of prying and tapping the crowbar. In the process of removing the transmission, we did pull the throwout bearing apart. I was planning on reusing it, but since it popped apart, well, shoot. And how I got this off, because this was pressed onto this collar, you know, flush. So there was no gap between this and the rest of that collar, and there's not really anything for me to grab. So I bought a new acetylene torch for the ring gear, but I actually used the acetylene torch to heat this up and tap on it. I was able to get it down a little bit, and then I used hammers and chisels to first wedge in there, and then to kind of push against it, and you flip it over in the vise and tap and flip and tap, and I was finally able to get this off. I had a spare throwout bearing laying around. I didn't actually have to buy one. This is a leftover for a different truck that I'm assembling. This throwout bearing is actually for like a 1985 Ford, you know, F600, something like that. It'll fit all sorts of the you know, heavier duty Fords. I ended up going with a Y-block throwout bearing for the F350. Then I'm putting the 5-speed Clark in. So it's because it has that bearing kind of face goes farther inwards, and the pressure plate is a little bit different between the Y-block and the F500. Despite both of those, you know, obviously Y-block is very different than a, say for example, a 361 or the whatever the 335 block, whatever the 460 block, you know, equivalent to that is. But they actually use the same input shaft, you know, between the, you know, the 50s and 60s Y blocks, and then the later on, you know, FE and the, you know, heavy duty, medium duty trucks. They went down to the smaller input shaft on the light duty trucks, probably because they decided that the big one just wasn't necessary, and they used the car size for the light duty trucks, and then they kept the Y block size for the heavy duty trucks. So anyway, that's a whole, but that's why I have two of these bearings. The only difference, I think actually the inner diameter is slightly different, so I'm gonna have to get one of these collars slightly machined to accept the Y-block one. But other than that, they're almost the same bearing, and so that's how I ended up with two of them, and I got one for this.
Yeah, man. There it is. So this is super crazy dangerous. That right there is Balin Mania, and we are gonna do something really stupid today. It was a terrible idea. Balin might die. It was making me uncomfortable. Go, Balin!
You riding this?
What the fuck is happening?
Balin said not to talk crap about this camera. It's a piece of shit.
This is so unbelievably sketchy. Why would you put me through this, you jerk?
That's the power of really old engineering.
It'd be nice if it didn't kill me. It's not required.
I felt it fucking pop.
Make a wish, everyone. Make a wish. Not okay. You went too far. This guy, man. This guy.